We're live. Okay, so we're talking about exponents today. Topic, we're talking about exponents. Okay? First one we're going to talk about is anything to the 0 power. Anything to 0 power is always going to be 1. Not x to the 1, but just 1. So you ready? 100 to the 0 power. Check it out. I know it's 1. 100 to the 0 power. 1. A million to the 0 power, 1. XYZ to the 0 power, 1. 10 pink elephants to the 0 power, 1. It's always 1, right? So I used to love to, and you may see a big, I remember making this big, huge problem with all this stuff in there, and I hit to the 0 power, right? And I would just keep my mouth shut and watch kids and go home. I was like, oh, you seriously going to solve that? Oh, just thinking, why? And then all they would have to do is like this whole huge ugly power to 0 power, spit down to 1, right? Oh my God. But mouth shut, because there was a lesson to be learned, right? Because as soon as I showed them, like, oh, dang. Okay, now the other is negative exponents. Okay, negative exponent. Okay, this is the part where when you see a negative exponent, I want you to do a few things. Okay, first, okay, make a fraction line. Okay. So you ready? Let's look at example 4 while we're doing this, okay? I see a negative exponent. I see to the negative third, right? It's a negative exponent, okay? So it's 2 to the negative 3. So first, make a fraction line. Okay? Just make a fraction line, okay? Because negative exponents are on the wrong side. They're on the wrong side. So second, move the term up or down. But you got to move it. It's on the wrong side. Okay? So if it's a negative exponent on the top, it moves down. So again, it's a negative exponent on the top, it moves down. Once you move it, it changes to positive, okay? If it's a negative exponent on the bottom, just move it up. It's that easy, okay? If it's a negative exponent, it's on the wrong side. Okay, so then move it up or down, and then third becomes positive. We get a positive exponent. All right, so back to example 4. Technically, it would be a 2 over 1. Do you guys agree with that? I mean, no, we don't normally need to write a number as over 1. We don't, but it helps in this problem because you need a fraction, right? So if I make it 2 over 1 or 2 to the negative 3 over 1, that just becomes a fraction. Now, here's the deal. If it's a negative exponent, move it. So in this case, we're going to move it down. We're going to move it down. So we're going to put the 2 to the third on the bottom. That's all you got to do. If it's a negative exponent, move it. Move it from up to down or from down to up. Either way, when you move it, it changes to positive, okay? So now, this problem's almost done, but then we need something on top. What goes on top? What goes on top? 1. Everybody agree with 1? Okay, now, what is 2 times 2 times 2? Because 2 to the third power is 2 times 2, which is 4 times 2. So the answer is 1/8. That's my answer. Okay. All right, let me keep going. Example 1 and 2 and 3 we'll go to, and then we'll come back to some negative exponents, okay? So first of all, example 1, 2 ways to do it. Oftentimes the easiest way is to write it out 3 times. I would go 4y, 4y, 4y. Because it is to the third power, so it means 4y times itself 3 different times. 4y times 4y times 4y, okay? 4 times 4 is 16. 4 times 4 is 16 times 4 is 64. And if you're not sure, just use a calculator. Seriously, if you don't know, if you're not sure, you can go 4 times 4 times 4. I mean, I don't care. 64. Believe me? So I'm going to have a 64y to the third power, okay? And again, I said there was 2 ways to do this, didn't I? Okay, that's one way. The other way is say, well, I don't want to write it out 3 times because I'm lazy. That's okay as long as you do something like this. Maybe you'd say, well, I know Mr. Davis is 4 to the third and y to the third. You get that? So I brought the 3 through. I made it 4 to the third and y to the third. Just brought it through. And of course 4 to the third is 4 times 4 times 4. Which way do you like better? Second way or the first way? How many people say first way? How many people say second way? Okay, good. I like the second way too, personally. Because what if this is to the 8th power? I don't really want to write them out 8 times, do you? No, and I can use a calculator to find out what 4 to the 3rd power is, right? By the way, to the power, it's that button right there. See it? It's that little tiny Chinese hat, right? I don't know what you want to call it. They call it a carrot. I don't know why they call it a carrot. That's the name of it. It's called a carrot. I don't know where a carrot comes from. That's called a carrot. Anyway, to the power of. All right. Example 2. That's easy. It's just going to be 8. You guys okay with the 8? Coefficients. X, y to the 3rd power. All right. And you guys learned this in Algebra 1. You guys agree with that? Yeah, you should have. You should have learned this in Algebra 1, okay? So that's just a review, okay? All right. Everybody okay with that? You did learn this in Algebra 1, didn't you? Good. Okay, now, example 3 is not, and I want to do it is not x squared plus 9. It is not x squared minus 9. It is not. It is not. It is not. Either one of those. It is not x squared minus 9. You know why? It's neither one of those. It's neither one of those because it really means x minus 3 times x minus 3 because it's squared, right? And it's times itself. Does that make sense? And then the way we're going to do it is we're going to go x times x is x squared. X times a negative 3 is a negative 3x. Negative 3 times x is another negative 3x. And negative 3 times negative 3 is a positive 9. Okay, I'll back up. So I did a FOIL, or double distribute. Right? Guys, right? X times x. X times negative 3 times x, and negative 3 times negative 3. Okay? So then the answer really is x squared minus 6x plus 9. Okay? You wind up with that middle term because you had to do the FOIL, right? And you guys remember that from Algebra 1 also? You guys remember that from Algebra 1? Okay, good. All right, example 5. Well, I see a negative exponent. So what did I tell you we need to do? Negative exponent. What's the first thing we do? It's a negative exponent. Let's make a fraction bar, okay? Make a fraction bar, okay? And what I really have is a 3 to the negative 2 and a 4 to the negative 2 because they both have the negative 2 power, right? Okay. So when you see a negative exponent, just write the fraction bar. Just start right there, okay? First step you do, okay? Because they're on the wrong side. They're on the wrong side. So this 3 to the negative 2 is on the wrong side. It's got to come down. It's that easy. And this 4 to the negative 2 is on the wrong side. It just comes up. It's that easy. These don't have to be hard. So let's see what I get, right? So I'm going to have my 4 to the positive 2, my 3 to the positive 2, okay? So when you move them, change them to a positive exponent, okay? So negative exponents are on the wrong side, move them, make them positive, okay? They're on the wrong side, move them, make them positive. Now it's easy. I'm going to get a 4 squared is a 16 over 3 squared is 9. Thumbs up? Does that seem pretty easy? Okay, negative exponents need to be moved. That's what you have to remember. Either up or down, okay? All right, example 7. Let's see here. There's 2 ways to do it. Let me do it the way that you would probably do it first, okay? Now, right off the bat, everybody looking up here. All eyes here, even Kenzie, hi Kenz. This is a negative 3. You guys agree that's a negative 3? That is not an exponent. That is not a negative x. That's just a negative 3. So leave it where it's at, okay? So I'm going to write this as a 2 over x to the 5th to start off with. Just to start. I'm done all of it. Just to start, okay? Because I brought the x to the negative 5 down, okay? Because it's a negative exponent, okay? Times, I'll just use parentheses, negative 3x squared. Now I didn't move anything there because I don't have a negative exponent, okay? I could make this over 1 if I wanted to. That might help me multiply, right? So I'm going to get a negative 6 x to the second over x to the fifth, okay? How am I doing? Two of these cancel two of these. That makes sense because I had x, I've got x, right? I've got x, I've got x, right? And I'm going to show it real quick so nobody's confused, but this is like x times x, so this is 1, 2, 3, 4, 5 of them. Cancel, right? You guys cancel, right? Or what's an easier way than cancel? What would you do? Come on, what are you going to do? I'm not going to cancel, I'm going to subtract. I'm just going to subtract exponents, right? And I do know that there's more on the bottom, right? There's 5 of them on the bottom, so that what's left over should probably go on the bottom. So I'm going to have a negative 6 over x to the third, okay? All right, now I told you there was another way, okay? How would I have done it? Now remember, the way I teach, so I always try and get it to everybody so everybody understands the most basic way. But when I do it, I might have done it this way. I can add exponents, right? You guys agree? I can add exponents, and I get x to the... So I can get a negative 6x to the negative 3. See how I added exponents? I multiply the coefficients, and then I add exponents, and then I know that's got to come down. Oh, that's the way I would have done it. Does that seem faster and easier? How many people like the second way better? Yeah, I knew. Once I show you the easier way, of course you guys do. Right? But I like to show both so you understand how it works, right? I will always annoy you, right, Sarah? I will always annoy you by showing you both ways, right? You know why? Because I want you to know why. Not just how to do it, but I want you to know why it works. Okay, turn the page. All right. Scientific notation. Now, there's two ways to do scientific notation. Two ways for sure, okay? But I'm not going to show you the hard way. I'm going to show you the easy way. The hard way is just to multiply, add exponents, okay? Actually, I'll show it the hard way. Nobody's going to remember after I show it the easy way. Should I just show the easy way?
Yes.
Use your calculator. Seriously, just use your calculator. Go, okay. Just exactly like it says. You go clear. You go parentheses 3.5 times 10 to the power of 8. Parentheses. So you got written down? Parentheses 5.2 times 10 to the power of 5. Okay? Enter. Now, E14. E14 is not the answer. Okay? 1.82 E14 is not the answer. What is it? What does E14 mean? What do you think? I mean, really, honestly, what do you think it means? Yeah. That's it. So you cannot write E14. That's a calculator way to write it. Mathematically, we are supposed to write it as 1.82 times 10 to the 14th. 1.82 E14 will transpose into that, and that's the answer I want. If you write this, I'll mark it wrong. Does that make sense? You have to transpose it times 10 to the 14th. That's the calculator. That's the calculator, okay? Calculator. That's the calculator answer. We don't want the calculator answer, but we just need to know what it means. It does mean times 10 to the 14th. Good. Nice job, Simon. Okay, how about example 10? Okay. The hard way is to divide and subtract exponents, or we're just going to use our calculator. Now, you got to be careful on this one because you need the, and write this down, put these in here, parentheses, parentheses. Please write that in because you need, in your calculator, you need the entire top to divide by the entire bottom. If you don't do it in your calculator, let me do it wrong first so you can see why it won't work. 9.3 times 10 to the negative third divided by 3.1 times 10 to the power of 8. Okay, what's wrong? Please tell me what the calculator is going to do. Anybody? Can you tell me what the calculator is going to do?
Negative 3 divided by 3.2.
Yeah, all it's going to do is divide those two. That's it. You guys agree? That's all it's going to do. It's not going to divide everything else. It's just going to divide that by that. Okay? And so you're going to, boom, get an answer. Well, it might. That might be right. Wow, okay, well, I'm going to use parentheses. Just be careful. Okay, let's try it. 9.3 times, because of order of operations, maybe, to the negative third. Parentheses, I'm going to go 3.1 times 10 to the power of 8. It is a different answer, isn't it? Right? It is different. So what's E negative 11 mean? What's E negative 11 mean? we're going to go 3 times 10 to the negative 11. Okay, you guys agree? So the parentheses made a difference because I got a totally different answer, didn't I? Right? Okay, last but not least, example 12, the hard one. You ready for the hard one? Can we do it? Are you psyched? Megan, are you ready for the hard one?
Sure.
Let's rock and roll on the hard one, huh? Okay, so what's the first thing we ought to do? What's the first thing we ought to do? Fraction bar, right? Make a fraction bar because I saw negative exponent. So just fraction bar, okay? Okay, should we move some things? Okay, the 9 and the 3, I'll just leave 9 and 3, but I will eventually divide that and make it a 3. I mean, I understand that you're probably going to do that right away, but I wish you every little step, right, Emma? Just, it's kind of annoying sometimes, but, you know. So, I'm going to move some things, okay? So, this x negative 3, it comes down. I'll make it x positive. You all right with that? X negative 5, I'll bring it up and make it an x positive. You all right with that? This y to the negative 4, I'll bring it up and make it y to the 4th. And the y to the 2, I won't move. Don't move the y to the 2. Do not move the y to the 2 because it's positive, right? It doesn't need to be moved. Keep it there. Okay, actually, this problem wasn't all that hard, was it? It's getting pretty easy now, isn't it? Okay, so my answer should be 3. You okay with the 3? 9 divided by 3 is 3. X squared on top. Y6 on top, and on the bottom technically is 1, but we don't have to write the 1, okay? We could write the 1 if we wanted to. You okay with that? Okay, believe it or not, we actually got done. You have a tiny little bit of time to get some problems done. So it's page 38, and I got a problem on page 10, okay? So I've got both.